friends, welcome to you all. Today I'm in ACE Preparation League. Here I'm going to deal with preparation strategy for mechanical and production and industrial technology. Especially I deal with this subject, material science. Myself, Madhu Sekhar, and I did my MTech from IIT Roorkee with a specialization of industrial engineering. I'm an ACE faculty, ACE Engineering Academy faculty from last 8 years. Now, here I'm going to discuss about this material science preparation strategy of GATE and ESE. Let us consider here not only this preparation strategy not only helpful for GATE and ESE but also other competitive exams, right? Now, first I'll discuss about GATE mechanical engineering. From material science, okay, from material science, if you consider the syllabus, there are 5 topics are there. The first topic is crystallography. So from this crystallography, basic type of questions like simple cubic structure, body-centered cubic structure, hexagonal closed pack structure, diamond cubic structure. This type of questions, the questions related to the structures like atomic packing factor, effective number of atoms, they'll ask you. So the structures are very, very important from this topic. And also, not only structures, sometimes they'll ask you questions from the Miller indices. They'll ask you questions from the planar density. And also they'll ask you questions from X-ray diffraction method, slip systems, the number of slip systems for BCC, FCC. This type of questions they'll ask you. Okay. And the second topic is material properties and testing. Okay, this material properties and testing is a very important topic, not only for GATE and ESE, but also for interview point of view, like interview of BAC, DRDO, ISRO. For these competitive exams, interview point of view, this topic is very, very important. So from this topic, what are the topics important? Do you know? The topics especially like true stress, true strain, power law of strain hardening, okay? The strain hardening effect, power law of strain hardening, and also the types of hardness methods like Brinell hardness, Rockwell hardness, and Vickers hardness methods. These are also important. And also like ductility, malleability, toughness, resilience, proof resilience, all these properties are important from this topic. Okay, for GATE exam point of view, from this topic, numericals they'll ask you. Okay, numericals they will ask you from this topic. And from the crystallography also, sometimes numerical, sometimes static data questions they'll ask you. Static data questions like atomic packing factor of body-centered cubic, this type of questions. In case of phase diagrams, I think most of you people think that material science is a theory subject. So you will think that theoretical type of questions they'll ask you like that. And some of you people won't like this subject because in your BTech you felt difficulty this subject. You felt somewhat difficult because this is completely theory and also new terminology, chemistry terminology, physics terminology also included in this topic. That's why most of you people won't like this subject in your graduate level. You just read some important questions and you got some good marks and you got pass. But here it is not like that. For GATE exam point of view, 99.99% numericals. So from this subject also they'll ask you numericals. Okay. From this subject also they'll ask you numerical questions. Okay. So the phase diagram, third topic, It is a very, very important topic. Out of all these topics, I'll give you guarantee that every year there is one question from the phase diagram. Here, there are basically two types of binary phase diagrams are very, very important, like isomorphous phase diagram and eutectic phase diagram. From the isomorphous phase diagram with an example of copper nickel is very, very important. And also from the eutectic phase diagram, the example of lead and tin phase diagram and iron cementite phase diagram. These three diagrams are very, very important for your exam. And from these three diagrams, numericals they will ask you for gate exam. Numericals they will ask you for gate exam, but for ESE exam, sometimes theoretical type questions also they will ask you. Okay. In this phase diagram, iron cementite phase diagram is a very, very important topic for your exam. Iron cementite or iron carbon phase diagram. Okay. Tomorrow I will explain about this phase diagram elaborately. Okay. The same time. And the fourth topic is heat treatment. Out of all 5 topics, the heat treatment topic is a very simple basic topic. Okay, theoretical type questions they will ask you from this heat treatment. Theoretical type questions, simple basic questions I will give you. Okay, and every year there is a question from this topic. There is a question from this topic. And powder metallurgy, actually this is a production technology, actually this is a production technology or manufacturing process, powder metallurgy, but it is related to the material science, that's why here only it is there, powder metallurgy. Okay, na? From this powder metallurgy, sometimes they will ask you questions, rarely, sometimes. We can't, I'll say less preference. Out of these 5 topics, I will give you less preference for this, but more preference from the phase diagram. Every year, there is one question from the phase diagram, whether it may be a 2-mark question or 1-mark question. And one more question may be from the crystallography or material properties, heat treatment and powder metallurgy. So most preference I will give you the phase diagrams. The second most preference is material properties. Third is heat treatment. Fourth is crystallography. Fifth is powder metallurgy. Okay. These are the topics for mechanical gate. Now see here the weightage analysis of a mechanical gate material science subject from last 4 years. In 2019, actually for mechanical 2 papers were there, set A and set B, that is morning paper and afternoon paper. In a set A, that is morning paper, one 1-mark question, one 2-mark question. And the afternoon paper, one 1-mark question, one 2-mark question, so 3 marks total. Right. Next, in 2020, set A, that is a forenoon question, morning paper, forenoon question, one 2-mark questions, 1-mark questions 2 asked, and 2-mark question, there is no 2-mark question. And for set B, one 1-mark question and one 2-mark question. This is 2020. And 21 also, if you see here, only one 1-mark question in the morning paper, forenoon paper, and in the afternoon paper, one 1-mark question and one 2-mark question. And in 2022, okay, in set A, 3 1-mark questions and one 2-mark question. This year, 2022, this exam was over, there is a more weightage here. So total how many marks? 3 1-mark and 2 5 marks total from this set A. But in the afternoon paper, the number of marks here it is only 3 marks. So from this overall weightage I am giving like 3 to 4 marks or 3 to 5 marks maximum. 3 marks minimum, maximum 5 marks, 3 to 5 marks. 3 to 5 marks, 3 to 5 marks from this material science. Listen, only 5 topics. From these 5 topics, 3 to 5 marks. Okay, it is easy to score 3 marks or 4 marks because out of these 5 topics, I am giving 100% one question from the phase diagram and one more question either from heat treatment or material properties or crystallography. Okay, and these topics are somewhat easy, okay, compared to other subjects, right. So this is the weightage analysis for gate mechanical. okay, gate mechanical. Now let us see some of the previous year questions of gate mechanical. See here, what type of questions they are asking, the standards of questions here. This is gate 2018 set 1. Then the number of atoms per unit cell and the number of slip systems respectively of a face-centered cubic structure. Now see here, this is a face-centered cubic structure. So in a face-centered cubic structure, okay, in a face-centered cubic structure, how the atoms are arranged? The arrangement of atoms are how it is like this. Now see here, in a face-centered cubic structure, okay, in a face-centered cubic structure, there are 8 atoms are arranged at 8 corners of a cube. 8 atoms are arranged at 8 corners of a cube, okay, and 6 atoms are arranged at centers of 6 faces, at center of this face 1, center of this face 1, back face center 1, right side face center 1, bottom face center 1, left side face center 1. This is a face-centered cubic structure. So the number of atoms per unit cell they are asking, effective number of atoms. Now see here, at each corner 1/8 fraction of the atom is present, like that 8 corners, and at each face center 1/2 of the atom is present. If I take a face, half of the atom is in one unit cell, another half of the atom is in the other unit cell. So at each face 1/2 atom is there. So if I consider the effective number of atoms, n is equal to, at each corner 1/8 of the atom, like that 8 corner atoms, plus at each face center 1/2, like that 6 faces are there. So the total effective number of atoms here, it is 4 atoms. 4 atoms, right? The first question is 4 atoms, but here this is not correct and this is also not correct out of these two only. But if we consider the number of active slip systems, okay, the number of active slip systems of a HCP structure, the number of active slip systems are only 3, and for FCC structure, the number of active slip systems are 12, and for BCC structure, the number of active slip systems are 48. This is actually based on the, okay, family of planes and family of directions you'll get. So for FCC structure, the number of slip systems are only 12, so the most appropriate answer is C, that is 4 and 12. This type of questions they'll ask you for your exam, right? Next, let us see here, there is another question from the phase diagram denoting L as liquid and M as solid in a phase diagram with the subscripts represents different phases. An Eutectoid reaction is described by. An Eutectoid reaction is described by. Eutectoid reaction is an equilibrium reaction. Okay, what this reaction represent? At a point, let us say at a exact particular chemical composition at a temperature, one solid phase directly transforms into 2 different phases. One solid phase transforms into 2 phases, right? See here, one solid transforms into 2 solid. Here M represents solid, okay? One solid transforms into 2 solids upon cooling. So this is the direct answer. Very simple question, okay? This type of questions also they'll ask you from the phase diagram. There are 3 important reactions are there. You should remember these 3 reactions, that is eutectic, eutectoid and peritectic reaction. These reactions you should remember for your exam. Now let us see one more question from the heat treatment. Here, the hardenability of steel is a measure of, okay. Actually the hardenability you will learn from the hardening process, okay. So you'll see what are the options given in the question. What do you mean by hardenability? First of all, I'll explain, then after that we'll check the options, right? Now see here, what we are doing here in the heat treatment process, in the hardening process, we are heating the steel piece up to above recrystallization temperature, that is up to austenite temperature. Then after heating, we are quenching the workpiece material in water. So by quenching the workpiece material in water, the outer layer of the workpiece material immediately transforms into martensite. It's a hard phase material, right? The outer layer of the material immediately transforms into martensite, but inner core of the material is present in retained austenite form. Okay, this is martensite. The outer layer is immediately transforms into martensite, right? So that martensite material is a high strength and hard material. So that martensite, how much depth it is there? Okay, it is the depth from the surface of the specimen up to which the martensite is present, that is known as the depth of hardenability. We can say hardenability. In a simple way, how much the high hardness, how much depth it is present in a workpiece material, how much depth in terms of mm or micrometer like that, how much depth it is present from the surface, that is simple we can say, right? Now see here, options if you see, the ability to retain its hardness when it is heated to elevate temperature, it's not correct. Okay, and the second one, the depth to which required hardening is obtained when it is austenized and then quenched. Quenched is nothing but cooled rapidly by quenching in water. So this is the most appropriate correct answer here. Now see here, option C, the maximum hardness that can be obtained when it is austenized and then quenched. Actually, it is not given here the depth. Maybe maximum hardness you will get, but how much depth it is there, that maximum hardness, that will give you hardenability. The ability to harden when it is cold worked, it is not at all correct. Okay, so the most appropriate or correct answer for this question is B. Now let us see here. This question actually from material properties and testing. It's a very simple and basic question actually. See here, the loading and unloading response of a metal is shown in the figure. This is a stress strain curve of workpiece material, loading and unloading. This curve represent loading and this curve represent unloading, right? The elastic and plastic strains corresponding to 200 megapascal stress respectively are. It's a very simple. Now see here, a workpiece material. Let us take a workpiece material. You are applying some tensile forces or a compressive forces. Let us take tensile forces you are applying up to the plastic region. Then after applying tensile forces, if we relieve the load, if we unload the workpiece material, the material simply follow the Hooke's law. The material simply follow the Hooke's law. Okay, and it won't reach to original state because there is some plastic strain. Okay, whatever the elastic strain present in the workpiece material, that is recovered, so that total strain is 0.03. So once after unloading, it is 0.01, right? So that means this much amount of strain is recovered, that is elastic recovery, or otherwise we can say it is elastic strain. And this one represent plastic strain, plastic strain. So how much plastic strain? 0 to 0.01. How much elastic strain? 0.02. Right? Now see here, options here. In the question it is given, first word is elastic word and the second word is plastic word, and in the question it is given respectively. That means in the option you should take the first is elastic strain, second is plastic. Elastic strain is 0.02, 0.02, plastic strain is 0.01. Right? Now see here, 0.02 and 0.01. See here, this is the correct answer. So for this question, the correct answer is C, right? Now let us consider one question actually from the cast iron material, okay? Right, now see here, the cast iron which possesses all the carbon in the combined form as a cementite is known as. Generally there are 4 types of cast irons. grey cast iron, nodular cast iron, white cast iron, malleable cast iron. In a cast iron material, graphite is present due to more carbon in it. Okay? And based on the shape of the graphite, we are dividing these cast irons. But white cast iron is different actually. In a white cast iron material, there is no graphite. Whatever the carbon in present in the cast iron material, that is combined into a cementite form. So there is no graphite, right? So that question directly they asked. Okay, other three cast irons have graphite, but this white cast iron do not have any graphite, but instead of graphite, the cast iron is having a cementite. So the correct answer for this question is C. Do you know the applications of white cast iron? In a white cast iron, there is no graphite in it. That's why this material is used as a, like we can say, crushing mills, rollers, okay, concrete mixers, these type of equipments. To make these type of equipments, we are using white cast iron. Okay, na? Understand clearly? Right. So the correct answer for this question is C. Now, one more. This is actually a 2-mark question from the heat treatment. It's a very simple question. Okay, astempering. Astempering is a heat treatment process. Okay, astempering is a heat treatment process. In this process, what we are doing, we are heating the workpiece material up to austenite. Then after that, we are cooling rapidly up to some 500 degrees Celsius. Then after that, we are applying an isothermal cooling. Okay, so by cooling the material like this, okay, by cooling the material like this, let us see the time temperature transformation diagram. Let us see the time temperature transformation diagram. The y-axis represent temperature and x-axis represent cooling time, T, time in terms of seconds, time in terms of seconds, y-axis represent temperature. Now see here, what we are doing, what is astempering process, I'll explain, listen carefully here. Let us take a steel piece. What we are doing, we are heating the steel material up to a austenite region, gamma iron up to a austenite region. And after that, we are cooling the steel material initially rapidly to escape the pearlite formation. We don't want pearlite, so that to escape the pearlite, we are cooling rapidly up to some 500 degrees Celsius. Then after that, we are applying an isothermal cooling, a constant temperature cooling, so that we will get a material that is known as a bainite. We will get a material that is known as a bainite. So direct question they asked, okay, astempering of steel is done for obtaining bainite structure. Very simple question. Very simple question. This is actually to get a bainite structure. This process is applied to get a bainite structure, right? Let us take another question. In a binary system of A and B, a liquid of 20% A, 80% B, coexisting with a solid of 70% A, 30% B, for an overall composition having 40% A, the fraction of solid is. This is actually a lever rule question. This type of questions also they'll ask you. Okay, the lever line, directly you can draw a lever line here. Let us consider on one side of a lever line I am representing solid, on the other side of a lever line I am representing liquid, and at the middle I am representing a point, chemical composition, that I am representing with 40% A, okay, and a complete solid where it exists at a 70% A, C solid will get at 70% A, and a complete liquid where you will get, complete liquid where you will get 20% A, complete liquid you will get at 20% A, right. Then mass fraction of solid, if you want to get the mass fraction of solid, how will you get? That is opposite half of the line, that is C naught minus C liquid by C liquid minus C solid, that is 40 minus 20 by, okay, like 40 minus 20, C solid minus C liquid, you can take here, C solid, let us take here, okay, C solid minus C liquid, that is 70 minus 20, so that you will get 20 by, okay, 50, 2 by 5. 20 by 50, 2 by 5, that is 40%, right? So I'll get answer is like 0.4. 0.4 answer you'll get. This type of questions also they will ask you, right? So I discussed the preparation strategy of this material science for mechanical gate. Now the same subject, but this subject is related to production and industrial engineering. Okay, production and industrial engineering, if I consider, the weightage of the subject is more compared to mechanical. The weightage of the subject in production and industrial engineering is more number of questions they'll ask you, some like 7 marks, 8 marks questions they'll ask you from this, and also the topics are also not only these 5 topics. These 5 topics are common for production and mechanical gate, but there are 2 more topics are also there for production. 2 more topics are also there for production and industrial engineering. What are those 2 more topics? Ferrous and non-ferrous alloys. Like they'll ask a question, what is Babbitt metal? It's a non-ferrous alloy. Copper alloys, what is brass? What is bronze? What is German silver? This type of questions, basic questions they'll ask you. And from ferrous alloys we already discussed, right? Like what types of steels and types of cast irons, iron cementite phase diagram, this type of questions they'll ask you. But you should focus on non-metallic materials, especially for production. Thus polymers, classification of polymers, structures of polymers, fabrication of polymers you should learn. Production technology of the polymers, injection molding, extrusion, this type of methods you should learn. And also ceramics. Ceramics are compounds of both metal and non-metal. You should learn about the ceramics also. And finally, composites. Composites are combination of more than one. Nowadays in the universe, most of the materials are composites because the application point of view, you are using advanced material. These advanced materials are combination of more than one. That's why we are using composites, right? These are the extra topics you should focus. Not only these 5 topics, but also these 4 topics you should focus to get good marks from material science of this production and industrial engineering. Now see here, the weightage of the subject here, the weightage of the subject, especially from this production and industrial engineering, see I'm giving the weightage analysis from 2017 to 22. Every year, like 5 questions or 6 questions they are asking, 5 questions minimum, like 6 and 7 questions maximum, like 5 questions means 3 1-mark question, 2 2-mark question, like 7 8 marks, and maximum up to 10 marks also sometimes for this subject, okay, right. See what type of question they'll ask you. This is actually a composite question, okay. This is actually a composite question, 1-mark question. In a glass fiber reinforced composite, that is ZFRP. Okay, nowadays we are using this everywhere. Wherever there is a high strength and high hardness and good ductility if it is required, there we are using. Good toughness, actually, good toughness, we are using this one. Composites with long fibers, okay, of glass. The role of matrix is here. Tell me what is in a GFRP, what is the matrix phase first of all. In a glass fiber reinforced composite material, the fiber is a glass material, okay, and matrix is a polymer. Epoxy resin we are using, matrix. What is the purpose of matrix? What is the role of matrix? That actually I'm going to discuss. See, the role of matrix is to protect the fibers and to give support to the fibers, to transfer the load from matrix phase to the fibers. But remember, if you apply a load on a GFRP, only matrix phase can't take more total load. it won't take more load because it's a low strength material. It will transfer the load. Okay. Now see the options here. Support and transfer the stresses to the fibers. It is absolutely right. The second, reduce propagation of cracks. It is also correct because the matrix phase material is surrounded by the reinforcement phase material, so it avoid the propagation of cracks and carry the entire load. It is absolutely wrong. Next, protect the fibers against the damage. It is also correct. Protect the fibers against the damage. It is also correct. So R is not correct and P, Q, S are correct. So the correct answer for this question is C. The correct answer for this question is C. Right. Now, let us consider another question. Okay, GATE Production 2020. In a uniaxial tensile test on a specimen of a ductile material, okay, the ultimate tensile strength is found to be 400 megapascal. Okay, ultimate tensile strength is 400 megapascal, and the elongation up to the maximum load is, okay, remember, elongation up to the maximum load is 25%. Now, the true stress at the maximum load. So, in the question it is given, ultimate tensile strength is nothing but the maximum stress in the stress strain curve. Okay, ultimate tensile strength is nothing but maximum stress in the stress strain curve, that is 400 megapascal. In the question, elongation is given. Elongation is what actually? Elongation is delta L by L into 100, that is nothing but 25% is given, right? So from this I can take it as elongation is nothing but a strain, that we can say it is an engineering strain. We can say it is an engineering strain, okay? That engineering strain epsilon E is equal to delta L by L, that is actually 0.25. Okay. Now they are going to ask, what they are asking? True stress at the maximum load. So true stress sigma T at maximum load, that is sigma ut into 1 plus epsilon E. This is a basic standard formula. Now from this 400 into 1 plus 0.25, that is 400 into 1.25, that you will get approximately, that you will get the exact value, that is 500 megapascal. Right, this type of questions they will ask you for your exam. This is actually a material properties and testing question. Right, now the next question, actually it is actually from powder metallurgy. In manufacturing of self-lubricating bearings, self-lubricating bearings means the bearing, it will continue in supplying lubricant. No need to add lubricant externally in every 2 days, 3 days or 1 week after, right, like that. By powder metallurgy, an important secondary operation that is carried out after sintering. Now listen carefully. The main drawback of powder metallurgy process is porosity. Pores on the surface or inside the workpiece material, because we are making components from the powders of different materials, right? So there must be some porosity. Generally, we can also remove this porosity, especially surface porosity, by coating some like a pillar metal, by applying some pillar metal, that we can say infiltration. But here we are going to use that porosity. We are going to use that porosity by adding lubricants to the pores. Let us consider this is a shaft. Okay, na? This is a shaft. This is a bearing. Okay, this is a bearing. To reduce the friction between the shaft and bearing, definitely we should add some lubricant. But every 2 days, 3 days we should add lubricant, and that lubricant after some days it is going to spill out actually. But what I am doing, I am producing a bearing by using a powder metallurgy process with some porosity. How can I generate the porosity? By applying less compactive pressure. so that I'll get some good porosity. And after making that component, what I am doing, I am going to fill the pores of that component with some lubricant, some oil. After that, I am fixing this bearing with the shaft, and this lubricant, whenever it is required, it is come out from the pores and it will act as a lubricant. It's a very interesting thing, right? That is known as impregnation. Impregnation. I usually give a hint in a class, okay? Impregnation, National Oil Corporation, oil, remember, oil. Impregnation, oil. We are going to fill the pores of a powder metallurgical component with oil, and this oil act as a lubricant. Okay, na? So the correct answer for this question is D. Now, perlite microstructure in Eutectoid steel consists of alternating layers of two phases, namely ferrite. Now, if you see the microstructure of a perlite, okay, microstructure of a perlite is like a fingerprint structure, okay. In a perlite material, thin lamellar forms of cementite, okay, thin lamellar forms of cementite and surrounded by alpha iron is present or ferrite is present. Now, this is a perlite microstructure. Here, this is a ferrite or a alpha iron, and this is a cementite. Okay. So, in the question, two phases, namely one is given in the question, ferrite, and what is the second phase? That second phase is cementite. That second phase is cementite. So, the correct answer for this question is A. Now, there is another interesting question, actually match the following question from the heat treatment. Let us see here. Here, in the list 1, they are given different heat treatment processes, and in the list 2, their result or objective of those processes given. Now, let us see here. Out of these, nitriding process is a case hardening process to increase the surface hardness we are applying. So, S is 1. So, this is not correct. Option elimination method I am giving. Nitriding, surface hardening. Right. Annealing process. Annealing process for what purpose we are going? Okay. Annealing process to relieve the residual stresses and to refine the grains also. But let us say here, let us consider here, Mar tempering is there, right? Mar tempering actually, okay, Mar tempering actually for what purpose? Listen, refining the grain structure or hard and brittle. Tell me, which is going to be hard and brittle? In which process you will get hard and brittle? Will you get in the annealing process? No, you will not get in the annealing process, right? So, we can say, will you refine the grain structure? Yes, we can refine the grain structure, but to refine the grain structure, most appropriate process is actually a normalizing process. So, I can say, I'll give you, okay, to relieve the stresses, normalizing process, okay, to refine the grain structure and more tempering process, I'll give you the fourth one, hard and brittle structure, Martensite you are getting. So, that's why here the most appropriate answer I'm giving D. Okay, no? Right. Now, this is the preparation strategy for gate production and industrial engineering, right? Now, the next topic, next one is material science for engineering services exam, Indian Engineering Services exam, ESE or IS, Indian Engineering Services, right? Now, the material science, if you take for ESE, okay, this material science is one of the most weightage subject. Most weightage subject. Very, very important topic. This is actually for your exam point of view. Very, very important topic. Because actually why I am saying this one is because this topic is also there in your GS. Okay. This topic is also there in paper 1. Paper 1, that is General Studies and Engineering Aptitude. Okay, this topic is also there in paper 2, technical. Okay, this topic is also there in paper 2, technical. Okay, and this topic is also there in mains. So, see here, very, very important topic this is actually. Okay, without material science, you can't, for ESC especially, because the most weightage topic, it is there in the general studies, it is there in technical, and it is also there in the mains, right? So the topics here for the material science of ESC is this technical. These are the topics related to technical. For general studies, some other topics also there. That is like electrical materials also there. I am not giving here. I'll discuss later that one, right? So here the topics are same as GATE, like crystallography, material properties and testing, phase diagrams, heat treatment, metallic or non-metallic materials, and listen carefully, nanomaterials. This is an advanced topic. Nanomaterials and preventive methods of corrosion. Corrosion is also a very important topic. In India, at least some 2% of GDP is lost because of actually the corrosion of material, steel material, right? So that's why it's a very important topic, right? So these are the four different topics, different units for ESC syllabus, okay? Not for GS point of view, okay, paper 1 point of view, not only these topics, but also electrical materials like conductors, semiconductors, insulators, magnetic materials, superconductors also there. For GS point of view, paper 1 point of view, no need to remember this nanomaterials because it's advanced method. That is, this paper 1 is common for all branches. That's why no need to read this nanomaterials. It's an advanced material actually, right? Now the weightage, if you see, for GSA prelims technical I am giving here, for technical I am giving here, for technical I am giving here, okay. Every year if you see, like 10 to 14 marks, 10 to 14 marks they are asking, 10 to 14 marks they are asking. I think questions, these are not marks actually, these are the questions, 8 questions, 11 questions, 12 questions like that. For basics of material science also if you take, for general studies and engineering aptitude also if I take, like minimum 10 marks, maximum, in 2018 they asked 17 questions. But in 2022 they asked 7 questions. And average 10 questions, 11 questions like that they are asking. On an average 10 questions for GS point of view. And technical point of view, on an average some 10, 11 questions like that they are asking. So more weightage this is actually. And also in mains, for mains also this subject is like 40 to 50 marks range is there. The average the mains weightage for this subject is actually 40 to 50 marks. So you should consider this topic, this subject, should not neglect this one. If you neglect, you may get rank, but you may not get a good rank below 10. Below 10th rank you may not get. Even for not only this ISC, but also for other competitive exams like state service exams, ISRO, BARC. In all these competitive exams, they are asking questions, like 8 to 10 questions they are asking from this material science. Maybe for GATE point of view, this is less weightage, but other competitive exam point of view, this is more weightage subject, right? Now see some of the questions related to ESC. Now see here, copper has FCC structure, its atomic radius is 1.28 angstroms, 1.28 angstroms, and atomic mass is 63.5, and the density of copper. For an ESC, in an ESC, calculator is not allowed. First of all, calculator is not allowed, but it's a numerical. How can we solve? It's a very simple error. Based on the units, by comparing the units, you will get the answer easily. By comparing the units, you will get the answer easily. Now see here, the copper actually, okay, copper density is actually 8.9 into 10 power 3 kg per centimeter cube gram. Actually, listen carefully, 8.9 grams per cc. This is copper. Grams, but here kg given. Let us take 7.58 grams per cc. This is for iron, okay, and 2.6 grams per cc. This is for aluminium. Metals, Okay. Now if you observe carefully, grams per centimeter cube, 8.9, 7.5, 2.6 like that. Now here these options are not correct. This is not correct because it's mm cube. This is meter cube, it's absolutely not correct. This is mm cube, it's also not correct. So the most appropriate answer for this question is C, without calculating. Even by using formula and calculator you will get the answer, but not required actually. Okay, very simple question. Next question, here it is, the Miller indices of a material in a plane are proportional to. Now listen carefully, the Miller indices are nothing but reciprocals of plane fractions, right? So direct question, reciprocals of numerical parameters of the intercept, so direct answer is given. Square is not correct, intercepts of the planes on the coordinate axis. Okay, reciprocal of numerical parameters of the intercepts, numerical parameters 1, like 1 by 2, 1 by 3 like that. And interplanar spacing is not correct. So the correct answer for this question is A. Now, next, the straightforward question, atomic packing factor of BCC. Direct question, okay. The atomic packing factor of simple cubic structure is, okay, 52% or 0.52 we can say. 0.52 is a packing fraction, packing density is 52%. And for BCC, it is actually 68% packing density, otherwise 0.68. And for FCC, it is actually 0.74 or 74% and diamond cubic structure it is 0.34 and hexagonal closed pack structure HCP structure if I take it is also 0.74. So the correct answer here it is BCC is given 0.68, right? The correct answer for this question is B. Now the next question, which one of the following is not a step of lever rule of a determination of phase amounts actually? Okay, let us see here, let us consider, if I consider a phase diagram of two metals A and B, okay, this is a phase diagram of two metals A and B if I consider, okay, this is a lever line, let us consider this is a lever line. I am going to calculate at this point, I am assuming this point is C0. The lever line is an isothermal line. This lever line is drawn in a two-phase region. This is C liquid and this is C solid. This is C liquid and this is C solid. Lever line is drawn in two-phase region. Okay. Now see the options here. Listen carefully, very important thing here it is. Very important thing here it is. Not a step actually, not a step actually. Okay. A tie line is constructed across the two-phase region at the temperature of an alloy. This is a correct step actually. Okay. Next, the overall alloy composition is located on the tie line. Yes, definitely the overall alloy composition, let us take this point, is located on the tie line, that is lever line. Perpendiculars are dropped from these intersections to the horizontal compositional axis from which the composition of each phase is represented. See here, will you get a like liquid phase composition here, like mass of liquid? Will you get mass of solid here? No, you will not get. You will not get mass of liquid and mass of solid by drawing a vertical lines. See here, perpendiculars from the tie line, right? So this is the correct answer because it's not given, not a step. So that is the answer for this question. So C is the answer for this question. Next. The indentation on a steel sample has been taken using 10 mm tungsten carbide wall at 500 kg load. If the average diameter of the indentation is 2.5 mm and BHN will be, it is actually a formula based one, Brinell hardness number, the formula based one, that is actually 2p by pi d into d minus root of d square minus d square. This is actually a formula based one. It's not easy, without calculator it's very difficult, right? Let us see here, 2 into load is 500 kg by pi into indentation diameter, this is actually capital D, this is actually a small d, indentation diameter is 10, sorry, indenter tool diameter is 10, 10 minus root of 10 square minus 2.5 square, right? Now see here, it's somewhat difficult, listen, but listen in a simple way. I'll tell you how to solve this question without calculator. Let us consider this term actually, okay. 100 square, that is nothing but, sorry, 10 square, that is nothing but 100. 2.5 square we don't know, let us take 2.5 square, you don't know. But 2 square is 4, 3 square is 9. So definitely 2.5 square is in between 4 and 9. So let us take some value 6, right. So 100 minus 6, let us take 94. Root 94, some rough value give me. Root 94, let us take some value if we get, okay, root 94, let us take 8 8 ja 64, right, 9 9 81, like some approximately 10 10, it is between 9 and 10, right, 9 into 9 81, 10 into 10 100, so in between this one. So let us take 9 and 10, let us take 9.5. And 10 minus 9.5, that is nothing but 0.5. So 0.5 into 10, that is nothing but 5. 5 into pi by 1000. Let us say simple, 1000 by 3.5 into 5. 3.14. 3.14 into 5. 3.14, let us take 3. 3 5 ja, approximately 3 5 ja 15. Right. So 100 by 15, approximately how much you will get? Sorry, 1000 by 15 approximately. Actually, by using calculator, you will get approximately 100. So it's a very difficult. Sometimes this type of questions also they'll ask you, but you should be careful. Some numericals calculator is required, but sometimes you'll get. It takes time. So that's why this type of questions you should solve after completion of all the questions. At the end, before submitting this paper, you should go through this type of questions, because otherwise it is going to consume time, right. Next, the TTT diagram shows the time temperature required for isothermal transition. Actually, the TTT diagram is to get pure light from austenite, so the most appropriate correct answer is A. Now recrystallization temperature is 1 at which, so what is recrystallization temperature? At a recrystallization temperature, formation of new crystals from a cold worked component is completed by heating the workpiece material. New crystal formation is completed. So the most appropriate answer for this question is new spherical crystals first begin to form and from old deformed ones when that is strained. Strained is nothing but cold worked. The cold worked component, by heating the cold worked component at a point of temperature, the new crystal formation is going to be done. The recrystallization temperature approximately 1/3 to 1/2 of melting point temperature. Remember. Next, the final question, let us see here. Statement 1, fiberglass is a polymer composite made of a plastic matrix containing fine fiberglass. Yes, that is correct. Okay. Next, fiberglass acquires strength from the polymer and flexibility from the glass. Fiberglass actually a composite material, okay na? Acquires strength from the polymer. Actually, it is actually a glass fiber reinforced polymer, okay na? In this glass fiber reinforced polymer, the reinforced face material is a glass, it is a high strength material, and matrix face material is a like a polymer, it is a matrix phase material. The matrix phase material is a low strength material. So this polymer will get a strength from the glass. So it is the second statement, what is acquire strength from the polymer, from the flexibility from the glass. Acquire strength from the polymer is not correct. Strength from the glass. So the statement 2 is not correct, but statement 1 is correct actually. It's a made of a polymer composite made of plastic matrix containing fine fiber glass. Right. Statement 1 is correct, statement 2 is incorrect. You are familiar about the options, especially for ESC point of view. Every year, 10 questions minimum, they'll ask you this type of questions. Statements questions, otherwise assertion reason questions. Do you know the options? The option A is what, statement 1 and statement 2 both are correct. And statement 2 is correct explanation for statement 1. Option B is statement 1 is correct and statement 2 is correct, but statement 2 is not correct explanation for statement 1. Option C is statement 1 and statement 1 is correct, statement 2 is incorrect. Option D is statement 1 is incorrect, statement 2 is correct. Now if you see this question, statement 2 is incorrect, so the answer for this question is statement 1 is correct and statement 2 is incorrect, so answer for this question is C. Okay, right. And one more question, Babbitt is an alloy of, it's a lead and tin alloy we can say. Babbitt is an alloy of copper, tin and okay, antimony. Here let us take here 90% of tin, 6% of antimony. Let us take 6% of antimony we are adding, 6% of antimony and 4% of copper. We can say otherwise copper tin alloy. So the correct answer for this question is D. Okay. So this type of questions they'll ask you for your exam. And finally, I'm going to give the reference books for this subject. One reference, best reference book is William D. Callister, that is Material Science and Engineering by William D. Callister. It's a very good book, excellent book, but it takes time, lot of time to read this one actually. Okay. And the second one is Material Science and Engineering by V. Raghavan. He is actually a faculty from IIT Madras. It's also a very good and excellent book. If you have a time, you just go through these books. You will get some good knowledge and also you will attempt the questions, GATE and ESE questions easily if you read these books. Okay. This is the complete information, and finally I am going to discuss about the preparation, what things you do during the preparation and what type of things you should not do for the preparation. See here, relevant to the exam. Okay, just go through the relevant to the exam. Don't consider other topics which are not relevant to the exam. Let us take, if you take a GATE, 100% numericals, you should focus on numericals. For if you want to go for ESE, numericals for concept, both important. So fix it, your target. What is your target? Is it GATE or IS? Based on that you should prepare. Next, concept. Okay, don't go beyond boundaries. Just go through the syllabus and just go through those topics only. No need to read other than these syllabus. Next, numericals, you should focus on numericals. Next, shortcuts, you should prepare a shortcut notebook, formula notebook. Then you should revision that notebook number of times. And finally, test series is very, very important. Okay, for every after completion of every subject, you just go to the test series. And you practice, you should learn from the test series, you should learn from the time management, how you are using time, what is your solvability, capacity, how you are able to solve the questions, this type of things, how you are recalling the formulas, all these things you will get to know from the test series, right? And finally, don't do research work. I think some of you people, let us take, some of you people will see the last 5-6 years question papers and they will do the research on the questions and they will decide that from only one particular subject or two particular subject, there are so many questions. We'll focus on those subjects and I'll get a good marks like that, most of you people think. But my humble request is, you should prepare all the subjects of basic fundamentals. Okay, you should prepare all the subjects of basic fundamentals, because for GATE and ESE point of view, same pattern it won't follow. For GATE point of view, every year there is a different IIT is going to conduct the exam. So their strategy is completely different. Okay, sometimes they'll ask you more questions from the production, sometimes they'll ask you more questions from the thermal, sometimes they'll ask you more questions from the strength of material, like that. But that's why don't follow weightage methodology. Even if you follow the weightage methodology, you will qualify with some good number of marks like 40, 50. You'll get a rank of like 3,000, 4,000, 2,000, but no use of that rank. If you want to get an IIT, seat. If you want to settle in one good PSU, you should learn, you should read each and every subject of basic fundamentals. Then only each and every question you are able to attempt the question, you are able to attempt gate question. That's why don't do research work, don't go beyond the syllabus, and you don't have time to read foreign author textbooks also. My request, I don't know, some of you people will try to read for one subject 2-3 textbooks you are reading, maybe that will consume your time. You should focus what is required, that only. You should practice as many as numericals. Okay? As many as numericals you should practice. This is the strategy for this exam from this subject. Okay? And what are the things required for you? Class notes, what we are going to give, that one in the class, and coaching material, previous year gate questions, previous year ESC questions, and we are also providing bits and bytes. In this bits and bytes, some 2000 questions are available. You should practice those questions and you should prepare short notes. So you should follow all these things. And so this is my preparation strategy, okay, from this subject. I hope you understand well. And now I am going to end this session. Okay, all the best for your exam.
My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you. My name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program. Thank you.